All right. Oop, oop. You got that? Okay. All right. Sorry for the delay there, folks. All right. Welcome, everybody. And thanks for coming to my talk today. First of all, before I get started, I just want to say I'm really excited to see all the people out here taking advantage of this great conference that Danny has put on. It's pretty amazing. I'm honestly proud and honored to be a part of it and speaking for you guys today. So again, thanks for coming to my talk. Let me set the stage for what I'm going to be discussing today. Basically, I'm going to be talking about large language models and vector databases, and how you can combine these two things using JavaScript to build intelligent systems. And through the APIs that are available today through large language models, you can really do this with anything. So the reason why I chose JavaScript is because, one, I've built solutions for clients doing this very thing with JavaScript. And then two, most developers have some experience with JavaScript, whether it's good or bad, but you can use any language to do these things. So the concepts we're going to be talking about today aren't specific to just JavaScript. Because the APIs are there, they're really just REST APIs. You can call on them and do all these exact same things with really any language that you happen to choose or be working with at your organization. All right, so a little bit about me. My name is Jake Orshalick, and one of my hobbies is actually riding bikes, whether it's road bikes or mountain bikes. But if you talk to the people I know, they'll probably say that my hobby is crashing bikes, because every time they talk to me, I'm injured somehow. In fact, I'm recovering from a wrist injury right now that hasn't allowed me to ride bikes for about the past 3 weeks. And I'm hoping it gets healed up soon. I went to the emergency room. They actually know me there because I've been there enough. So, after the x-ray, thankfully it was negative. It was just a contusion, is what they call it. So hopefully it'll be healed up soon. I'll be right. I am a 2 times Ironman. I don't do triathlons anymore. They are brutal. I don't recommend them, but if you do have this goal in mind, I see that anybody can do this. Really, it's just dedication, working hard, and spending the time and effort to get there. So if it is something that you want to achieve in your life, good on you. I won't do anything. I am a coffee addict, and the fact that there's unlimited coffee out there is a problem for me. Okay, so if I start going too fast, I apologize. It's because I've had way too much of that unlimited coffee. Now, what you guys are interested in, I am a software consultant, and I have worked as an independent consultant for a little over 15 years, and I've spent a couple of decades building software. And I've worked during that time for my company, Focus Dev Solutions. And I've had the honor of being able to work for quite a variety of clients across a lot of different companies. And I love what I do. It's because I get to go in as an outsider and take a look at their business domain, try to understand it, figure out what problems they have, and then decide based on my technology knowledge how we can solve them. So maybe automate something to increase their profits or increase their efficiency or both, right? And so that's what I love doing. We need to keep doing that for years and years. And the technologies that we choose and that we work with, they may be older technologies, they may be brand new technology because we're solving a new problem that nobody's ever solved before. But that's the fun, right? Is trying to figure out what technologies are going to fit their specific problem depending on the context. The keynote today was talking about how everything is context, right? And that's what's important, right? You have to understand the context of that business and how they do business and what they're doing, what their problem is that you're trying to solve. All right, actual footage. Okay, so I am not here to hype up large language models or AI in general. All I'm here to do is tell you that they are a new tool in your toolbox. Okay? If you listen to OpenAI or their CEO, Sam Altman, they're going to tell you that LLMs are the future, that AI is the future, that AGI is coming. It's going to take your jobs. It's going to replace software developers. Well, whether that's true or not, I don't care. Right? The truth is that as developers, we need to understand the tools that are available to us and be able to use them to solve problems. And LLMs are really just another tool. So for them, for OpenAI, they want you to apply it to everything. They say it's the problem for every single situation. But the truth is we have lots of tools in our tool chest, right? whether it's web services or events or whatever it is, right? There's talks about all these different things today. To learn about all the tools we have. And the key is understanding those tools and applying the right one to each case. We really have to understand the context of the problem and say, okay, in this particular situation and based on the dev team and their experience and what they've worked with in the past, we know what the best solution is for this particular problem. And that's the fun of being a software engineer, right? Is that we get to do that. How many people get to really solve unique problems all the time? A lot of jobs are really focused on just doing the same thing over and over again. That's not us. We get to do all kinds of interesting things all the time because we're trying to solve problems that maybe have never even been solved before. All right. So back to large language models and our conversation for today. I like to tell stories. And the reason why I like to tell stories is I think we remember things a little better if it's all based around a story. And this story is loosely based on a true story. I love when movies say that, loosely based on a true story. Do you know what's really true here? But I was working with a large private equity firm with a small internal tech support team. And as you can imagine, if they've got a pretty small team, it's pretty tough to support everyone whenever, you just have a small staff. And the problem is that the firm was losing productivity due to wait times. And when you've got all these people in the financial field, where financial people are really impatient, right? They've got trades to do, they've got money to make, time is money. It's too much time spent just sitting on the phone, waiting for some support person to answer their call so they can get access to the system that they need access to. They can contribute whatever it is. And the cause really was just too many support tickets for a limited staff. So if that was the case, they started looking at how can we solve this problem, right? Some root cause analysis, trying to identify what we can do. Well, there was no budget to hire more tech support. There's one there. These tech people aren't that important. Tech support knowledge was spread among multiple sources. And this was a bit of a problem because if a tech support request came in and I'm trying to solve it, well, the question becomes, where do I go to get that information? Maybe I know the answer, but a lot of times I don't. And so I go off and refer to some wiki documentation or look through the resolved support tickets. Maybe somebody wrote the ticket that was similar before, and I can go through the 56 comments that are there and try to figure it out. Or I can talk to another support representative and say, hey, do you know how to solve this? Right? But the problem is this all takes time. There's a lot of time associated with that. Now, they thought first, well, maybe we can work faster. We got limited people, but if we had a knowledge base that would tell us how to solve every single problem that's out there, we can just refer to that. Right? I don't have to go to all those other sources. I can just have this one single place where I can go, and I can find solutions quickly to every single problem that comes in. Okay. So what did that look like? Well, you have these end users who either phone in, they send an email, or they create support tickets. And then the support person, either they know the answer or they have to go search for a solution. Well, it's the same thing as before, right? The only difference is that now they have these knowledge-based markers that they refer to first. That didn't work. Then they go down the other paths, right? They look at the wiki documentation, resolve support tickets, or ask somebody else. And then now they have this extra step where if they had to solve the problem and ask somebody else to do documentation, they create the documentation, right? They add to that knowledge base. So hopefully next time they can answer the question quickly. Now, these knowledge base articles, they were helpful, but now they have to spend more time documenting. And as the number of articles increased, it was difficult to find what you were looking for with a keyword search. Right? You just type in some keywords. Oh my God, there's 15 articles here. Right? Which one is the right solution for this specific problem? Okay. And then they don't address the real problem, which is too many support requests for a limited staff. Right? That's what we said at the beginning. That was the problem that we have to solve. But there were some interesting observations here. Number one, about 35% of the support tickets were simple step-by-step solutions that the user could probably handle independently. If they just had a guide, they could just walk through those steps and say, oh, okay, boom, 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 done, fixed, there you go. And then if the users handled just half of these on their own, it would reduce wait times by at least 50%. You know what? We got a business case here, right? And that's what's important. Anytime you're building a software solution, you should always be looking at the business case. What is it going to do? How is it going to, make that business more efficient and save money or make money? Right? Those are the two things you should be concerned with. So the first step, we thought, well, maybe we'll put a support chatbot in there, where end users can ask it questions, and then, if the support chatbot can't help, then, they forward it on to the support representative. Okay, so it's a step in between to try to save some time. The problem is that if you just stuck ChatGPT in there, it's happy to make up answers to things. Right? You ask it a question, you say, hey, how do I get access to Workday? Well, it knows about Workday. It's got that information from its training. It knows about that. But it doesn't know anything about the context of the organization. Right? How do we do it within our organization, within where we are and how we do things? So it'll just make up answers, and it's probably not the guy than anywhere useful, and then it's going to waste more time before they talk to somebody. So the solution to that is AI grounding. And really, AI grounding is just giving the model a proper information to act on. So it's a large language model plus a data source. Okay, some data source that includes the information that is necessary to answer the question that is being asked. Okay, within the context of our organization. All right. So what does that look like? Well, it changes our diagram a little bit, where now we have this help desk chatbot as before, but those knowledge base articles that are being created by the support team as they're creating and working tickets, now they feed back into this help desk chatbot. Okay, and that's the information that it acts on. That's the context. That's what we're grounding the AI in. So that whenever they ask a question, it gets back proper articles, and then it can base its response on that. And LLMs are really good at that, right? You give it a lot of information, useful information, and it can summarize it and put it into a good form so that it makes sense to those users that are asking questions. The main approach that people use to solve this problem of AI grounding is called RAG. Retrieval-Augmented Generation is what it stands for. We love our acronyms in the software. But this is the main solution you'll see online where you talk about combining LLMs with a specific data source. Now, ChatGPT does this. And if you use ChatGPT, what you'll see is there's two different cases. Well, actually, there's many more cases these days because they've incorporated agents and things like that. But these are two possible scenarios whenever you interact with ChatGPT. You might send it a prompt. It'll call back to its backend API, which calls into an LLM. In this case, it's GPT-4o. It's just one of their models, right? They have a bunch of different GPT models. But the completion it returns, like if you asked about who is the Beatles, it probably has enough training data from all of its training data across the web, the trillions of tokens that it's been training, to give you an appropriate response. Okay? It doesn't have to do anything. It just knows that information from its general training. But what if it doesn't know the answer? I'm a bourbon aficionado. I collect bourbon, and there's always new reviews coming out, just like with anything that you can collect. And there might be a new bourbon that's been released by some distillery, and the reviews for that bourbon are brand new. Maybe they came in the last couple of weeks. Well, if a large language model is only trained on stuff up to maybe the beginning of 2023, because they can't recreate these things all the time. It's very expensive to train these large language models. Millions of dollars worth of computing cycles. So what can it do then? Well, you call into ChatGPT and it will realize, hey, I didn't have that information. It'll go out and query and make a web search. And those results that get returned, it creates a call chain. For those results that get returned, it provides back into a prompt that, the question that you asked, plus those search results in order to generate a completion. So now you have the information it needs, even though it wasn't trained on those reviews. And it'll give you a good response based on the bourbon that I want to hear the reviews in and understand if it's good. So the completion also includes what's called citations. And those citations are actually links to the information. Greg got all the information that it's creating its response. So that's useful because if you look at that, you can make sure that what it's telling you is actually valid. And that's actually and you can also click into those and get more information, just in case this response is kind of a summary and you want more detail. All right. So in our case, for our customer support team, going back to our story, What if we ask the system, can you help me log into Workday? Well, the thing that we would need to do to ground the AI appropriately is we need to go get articles first that are related to that, knowledge base articles. And the prompts that we would create would have the context of two articles here: how to log into Workday and resetting your Workday password. And these are articles that were created by those customer service representatives. So we know they're specific to the context of how you would do that within the organization. And then you include the question, can you help me log into Workday? Now the LLM knows enough information to generate a proper response. And generally, when you create a prompt like this, you'll also tell, hey, base your response on this information, the context I gave you. Okay, so what does this look like from a practical standpoint? Well, when we ask questions to the help desk chatbot, now we send the prompt in to our API. It goes off and queries what's called a vector database, all right? And a vector database returns semantic results. And what semantic results are is it's going to find knowledge-based articles that are related to the question being asked. And this is the magic of a vector database, is it understands the question being asked. And finds articles, the articles that are embedded in that database that are an appropriate response to what you're asking. Right? And those results can then be sent in with our prompts to the LLM, which in this case is GPT-4o, and that finalizes our call chain, and then we can create appropriate completion to tell them how to log in to Workday and give citations. So they can click into those articles and see the actual knowledge-based articles if they choose to. Okay? And as you can see, we've got feedback here happening, right? So as new knowledge-based articles are being created, they get loaded into that vector database from the knowledge-based database, and boom, we keep making that chat smart. And now we can try to reduce the number of support requests that are coming in because those end users have a way to solve it. The chatbot is guiding them in the right direction. All right, so what did we use to solve this problem? Well, as JavaScript folks, you probably know some of these technologies for sure: React, Express, and Node.js. And this was the front end and the back end. It's where we built in order to interact with the user through that chat and then call back into the services that we were using behind the scenes. Everything was deployed out onto Azure, and we used Azure AI Search as our vector database. Then OpenAI was the provider for the large language models that we were using in order to put everything together and get appropriate responses. And the great thing about Azure is if you are interested in using OpenAI models, it has direct integration because of their investment into OpenAI into all of their models, and you can use them within the data governance of the Azure space. So you're kind of assured through their user agreements, so they say, that your data will not be used in any way or be confiscated, so you don't have to worry about it, okay? Whereas if you're calling into OpenAI APIs directly to people or to other LLMs, people are concerned about their data being leaked. So that's the consideration you have when you're using Azure with OpenAI. Now, the thing you may not be familiar with here is Langchain. And Langchain was actually originally created for Python, but there is a JavaScript version that's right. And what it does is it allows you to integrate LLMs, really any LLM you choose. It's got, it's agnostic. It works with all the different LLMs. But integrate them with approaches to building LLM solutions and integrating them into your applications. So it does have a lot of options for a RAG solution, right? Which is what we're talking about today. So some considerations that we're going to talk about and show code and how you address these when you're building a RAG solution are, number one, LLMs are statements. And unless you fine-tune an LLM, which we're not going to talk about today, it won't remember the information you send it. So regardless of whether you send a prompt and you ground it with several articles on how to solve something, it's not going to remember that in the next request unless you send that information again. You maintain like a history of the conversation you've had so far. The other thing is context windows. Context windows are the limits on the amount of data you can send in a particular request to it. So if I piled together 30 articles, I send all of that with a question and some instructions to the LLM, it may exceed the LLM's context window, which means it's just going to reject my request. So we can't just send whatever we want. And the other problem is you start running into runaway costs. So the way generative AI services usually charge you is based on token-based pricing. So what that means is that when you count the number of input and output tokens, so it's both the inputs and what it's generating for you, and multiply those times some fraction of a cent, you get the cost of every single request. Okay, so it's important to keep those requests as small as possible, the input and the output. And if you've never heard of tokens before, don't worry, we're going to talk about what tokens are and how you can figure that out in just a minute. And then also performance and accuracy. Okay? Results can definitely be impacted by excessive or unnecessary input tokens in the request. So if you have a bunch of junk data that you're sending in that's unrelated to what's being asked, it's just going to give you junk in the response, right? It's garbage in, garbage out, as with any software solution. Okay, and then performance is also impacted by the number of tokens you're sending in. So it's important to keep that in mind. All right, so the RAG concepts that you need to understand in order to be able to address these problems are embeddings, vector databases, tokens, and chunking. And we're going to talk about each one of those. So number one, what are embeddings? Well, if I call in, and there's APIs provided by a number of LLM providers, but today we're talking about OpenAI. So they have embedding models that you can call into an API, send it a string, and it generates what's called an embedding. Okay, so can you help me log into Workday results in what looks like an array of 11, right? An array of numbers. And those numbers are an embedding. It's also called a vector. Okay, and what a vector is it's really just a point in space. So if you graph this in a multidimensional space, and if you're a math person, which I'm not much of a math person, so I took linear algebra and I understand a lot of stuff happening behind this, but I don't like it. I just want the system to do it. So, but really it's a vector. It's a location in space so that you can start mapping things out in a multidimensional space. And if you look at it, and don't worry too much about the math here, but if you were to look at it in a multidimensional space, you would see something that looks like this, where there's a bunch of dots around for the different particles. And then if we ask it something, if we say, hey, can you help me log into Workday? You'll see the vector, the point on the graph here for the multidimensional space is very close to certain articles, right? How to log into Workday, resetting your Workday password. It kind of touches those, right? Because it's mapped closely to it. And that's where the semantic understanding comes in. These embeddings, because they're plotted somewhere in this big multidimensional space, it's close to something else, and that tells us what we're looking for. Okay, and that's how it figures out the semantic meaning between things. And this is really a lot of the magic of large language models. It's part of the secret sauce. So this is what the code would look like if you wanted to use JavaScript and Langchain in order to generate one of these embeddings. So if I asked it, can you help me log into Workday? And I use OpenAI embeddings here, which is one of the components. And I told it I wanted to use the model text embedding through small, which is one of their latest models for generating embeddings. This is what it would return. Now, if you look at it, it's huge, right? The vector that it generates is very large. And we don't need to be worried about that. It's a very large multidimensional space, but again, it does this automatically for us. We don't have to be worried about what it's generating. We just know that by doing this, it's going to start to understand the semantic meaning of what I'm asking and how it relates to those articles, the stuff I want to be able to return. So, as I said, a secret is that embeddings are part of the secret sauce of large language models in general. You can't see anything behind that, but we can actually see what's below. Oh, sorry about that. Well, never mind. But text, images, and audio clips are all converted to embeddings, like these vectors, so they can be mapped into that multidimensional space. It can relate things. And that's how it understands things. It doesn't understand them because it's text, because it's an image, whatever. It's turning it all into points, right? And mapping it and saying, okay, what's related to what? That's how it understands language. Yes? Okay. So this is how you would load a vector database. Right? You would send in a string, all the strings for our various articles. And it would generate those embeddings and then populate them into a vector database. And when you see it there, you'll notice that things that are related, these are all related to Workday and gaining access. They're all kind of close to each other in the vector database, okay? And this is using Langchain to load a vector database, okay? So we load up a bunch of text files, which are our articles, and they might be loaded into directory. This is the articles directory. And once they're loaded up, all we have to do is create an OpenAI embeddings instance, which is what we did before, and pass it in. This is actually an in-memory vector store, okay? HNSW lib. There's a ton of them out there. You can use vector databases that are hosted, out in the cloud, through a hosting provider, or out on Azure. We use Azure AI Search, but there's a lot of them available to you. And there's integrations through Langchain to all of those. Like, there's a bunch of plugins to allow you to directly integrate with them. But the key thing is that we pass in our documents and an embeddings provider, and it will go ahead and load up and vector store automatically for us without us having to do the manual calls to generate those embeddings. Okay. So what does this end up looking like? Well, if I ask it the question, can you help me log into Workday? It generates, our embedding. We're calling that embedding provider. Calls into the vector database to find out the articles that are related. So it looks in that multidimensional space and says, oh, they're right. Returns them as a result. And then we have the information we need to generate that LLM prompt, right? With the context, the way we're grounding the AI with those two articles, how to log into Workday and resetting your Workday password. And then including our question, can you be logged into Workday? And then GPT-4o receives the request and it generates a response. Okay, an appropriate response, because we grounded it on the appropriate information based on how we do things in our company, right? And the articles that have been generated by those customer support representatives. Okay. So we talked about the importance of tokens, right? Because the cost that you're going to pay for these requests and also the context window that you have available to you is important to know how many tokens you're sending in. So in this case, if we're talking about tokens based in words, you can see that if we simply split up, can you help me log into Workday, it would be 7 tokens, right? It's just based on word. But the truth is that models work a little bit different. They're usually based on words, subwords, and sometimes based on characters, right? So it depends on how the model works to know how the tokens are determined. And if we look at a good example here, this is how you can determine the tokens based on all the models that are provided by OpenAI. So tick token is the library that you could use to count the tokens in a particular string. And you can see we had 7 tokens if we did it by word for can you help me log into Workday. Here it actually returns 9 tokens. And it also logs out an array of those 9 tokens. And you can see they're all IDs. And this is actually how the model works behind the scenes. It doesn't actually use the words. It doesn't care about them. It uses those embeddings, which are a bunch of vector numbers. And words actually converted to an ID. Okay? Not exactly the words, the tokens are converted to an ID. And it has a lookup table. So if you're trying to get back, so if it's trying to generate a response, it says, oh, hey, I got all these tokens that I'm figuring out are supposed to be the response. Well, it actually has the IDs, and it goes and looks up every token in order to generate the response that you're seeing. So that's really the magic behind it, behind the scenes. It makes things much more efficient because it's really just using numbers instead of a bunch of text. So how do we reduce the tokens? Well, we can chunk things. We can split up an article into a bunch of chunks. So if we have this article that's maybe 10 pages long, no problem. We just break it up and turn it into text chunks before we store it off into our vector database. And then when we return the results, we only get the chunks that are important for what specifically is being asked. So when you're chunking, the advantages are that smaller chunks of text actually capture fewer topics or ideas. And what that means is that the embeddings end up containing more focused meaning. So this means it's going to improve your retrieval accuracy. So when you ask a question, it's more likely in that multidimensional space to find exactly what you're looking for, like the chunks that are important based on specifically what you asked. Okay, so that really helps with the information you're giving back to those people that want answers from that help desk support chatbot. And then we can avoid hitting token limits while generating the embedding. So every model, whether it's an embedding model, or whether it's an actual LLM, it doesn't matter. They all have token limits. You can't just send in as much information as you want and expect it to work. It's going to stop you and reject your request if you send in 30,000 tokens and it only accepts 15. So really the goal is in the end to have chunked query results so that we provide fewer, more relevant tokens when we're making the request to the LLM to reduce costs and also get a better response. And this is what it looks like with Langchain. So if we were to split an oracle up and provide this text, and we give it a chunk size of 100 and a chunk overlap of 20, it's going to break this article up into this. And this array is 3 elements. Now, in most cases, your chunk size is going to be much larger than that, so I highly recommend you look into it. But 1,000 characters and 200 for overlap is the defaults for that Langchain recursive text link. But here, for the purpose of example, we provided a smaller chunk size. And you can see the overlap, right? So the reason why it does this, and you see the overlap between the chunks, is so that it keeps those things closer in meaning whenever it's putting the chunks into that multidimensional space. Because if it's got overlap in the text, it's going to know those things are related. That somehow the meaning between those and the relationship between those keeps those chunks somewhere near one another in the graph. So if you looked at the graph after chunking and you have that overlap, what you'll see is that, like for instance, how to log into Workday, even if it's broken into 2 chunks, they'll be right next to each other. Okay, thanks for that. Same thing with resetting your Workday password and accessing Workday outside the company network. All the chunks are kind of near each other in multi-dimensional space. And there's other ways to do this, like providing metadata. And the metadata can also help with keeping things grouped together in multi-dimensional space. All right. So if you want to dive deeper into this, I highly recommend, number one, looking into prompt templates. And templates are kind of a template around how you would make a prompt request. So generally, you want some instructions to the LLM on how it should behave. So like, for instance, in the prompt we're generating there, you can tell, hey, base your response on these articles that I'm giving you, right? Don't just make something up based on what you've been training. Base it on what I'm doing. And then, maybe some more instructions on, hey, you're a customer service representative, act like, don't give a crummy response, so be nice to me. Like, so you want to make sure the LLM is instructed appropriately. Also, streaming responses. So when an LLM is generating a response, it generates it token by token. So as those tokens get returned to you, you can actually stream them back to the user. You can see that when you're connected to ChatGPT. It's actually streaming out that response to you so that you feel like it's moving really fast. And then also conversation history. I mentioned this a little, but as you're working in a chat, you can imagine, since their statements, right, the LLMs don't know anything in the previous request, you have to hang to all that conversation history and send it again and again so that it knows what you're talking about. Because if I ask a question about something we were talking about, maybe 3 steps ago, and I don't have that conversation history, it has no idea how to answer that question. And it doesn't know what we're talking about. So you have to keep that going. Tokens in that case, right? Because you don't want to go over that context with them. So you have to drop off pieces of the conversation history in a smart way, okay, over time. All right. So I covered a lot of concepts here, and I talked about a lot of code that went really fast. But if you want to get a good start on all of this, you can access my free ebook here. And I'm adding to this. Right now, it's a pretty basic introduction to get you started with JavaScript and RAG, but it'll guide you far enough that you can kind of get started. And then once you've done that, be aware that later this month, I'm going to start releasing some new things into this. And then early next year, I'm going to release a piece on fine-tuning. So if you're interested in fine-tuning an LLM, there will be content on that early this year. But I'd love you to connect with me and check out my ebook. And thank you very much for attending today.